Good evening and welcome to my presentation on algal-derived biofuels. Today's world is a volatile place, constantly growing and changing. The demand for energy is growing at an alarming rate. This increase in demand can partially be attributed to the emerging industrialized markets in China and India. The rest can be laid at the feet of modern medicine, as the average lifespan of humans has greatly increased during the last century. The world's energy problems do not lie purely on the demand side of the equation. There are significant problems on the supply side as well. Natural disasters, such as hurricanes, constantly threaten deep-sea oil rigs. Although technology has made this type of drilling much safer over the course of its lifetime, accidents can and do happen. When they do, the environmental costs can be staggering. As research by Keith Sparks in 2006 indicates, when the world warms, oil-rich countries produce terrorists, pollution reaches all-time highs, and oil prices fluctuate wildly. The need for a reliable, renewable energy source is becoming ever more apparent. But which form of alternative energy will be the most effective? In this presentation, I will show that algal-derived biofuels are the most effective form of alternative energy because they are not subject to service interruptions. They do not adversely affect the world's food supply, and they are inexpensive to produce. From the advent of the alternative energy movement, providing a consistent flow of energy has been a problem that's been difficult to solve. Early technologies relied on the elements, which are by nature inconsistent, and so could not be utilized as a sole form of energy production without major service outages. Research from Science Daily in 2008 shows that algal-derived biofuel solves this issue because it's not subject to intermittent outages due to changes in the elements. In fact, unless we run out of wastewater, incident sunlight, or greenhouse gases, the things that are needed for algal feedstock to grow, there is a minimal chance of any service interruptions with this type of energy. With this problem solved, what then on the impact of alternative energy on the world's food supply? As stated in my introduction, the world's population is exploding, and people's lifespans are increasing. Because of this, the world can ill afford to replace food crops with energy crops, as this would just drive the cost of food up in direct relation to the energy prices dropping. This rise in costs is especially hard on the poorest countries, which import most of their foodstuffs due to droughts or political situations. As shown in studies done by Haag in 2007, algae refineries can be placed on non-arid land, therefore eliminating the need to displace any food crops at all. Space for refineries also plays a role, as they can have a very large footprint. Diesel plants are very large, and not to mention a big source of environmental concern. Algal refineries need very little land and can go vertical as high as necessary. According to research done by Valerie Smith in 2011, if we were to replace all diesel refineries with algal refineries, we would only need an area of land equal to 1/2 of 1% of the land needed for our current diesel refineries. But what about the cost? Today the world economy is in decline, and the costs on anything that have to be transported has gone up with the steady rise in gas prices. In this environment, only energy sources that can compete with the price of regular petroleum will be viable. As studies done by Picos and Darzan's 2009 show, algal-derived biofuel fits this criterion. With currently highly productive algal streams, the cost to produce 1 gallon of biodiesel is $2.50. But is algae the most efficient form of lipid-producing plant? The chart behind me was made to answer this question, using research done by ExxonMobil in 2010. It shows the current difference in yield between the currently available lipid-producing sources, corn, soy, palm, and algae. The lipids produced are shown as per acre per year. The gallon yield for algae is 2,000 gallons. The yield of palm oil is 650 gallons, and the yield of corn oil is 250 gallons. The yield of soy oil is just 50 gallons. This means that algae is the most efficient and can be grown in less space, reducing the amount of space needed for a production facility. Algae have an additional benefit: they can be grown on non-arid land so as not to displace traditional food crops. This fact means the sites of new algal biorefineries will be less likely to be contested, which will result in more biorefineries. This will result in more skilled jobs and help put more Americans back to work. This fact makes algae not just cost-effective and efficient, but helpful to our stagnant economy. In conclusion, studies show that algal-derived biofuels are the most effective form of alternative energy because they are inexpensive to produce, they are not subject to service interruptions, and they do not adversely affect the world's food supply. This green energy of the future not only will solve the problem of energy independence for the United States, but will help reduce global warming by reducing the amount of carbon dioxide being pumped in our atmosphere. The jobs created by this new industry will bring much needed, good paying, middle class jobs to the American economy. It may be a few years before algal-derived biodiesel hits the mass market, but there can be no doubt that algae is the real green energy of the future. Thank you. I can now take some questions.
What about the risk to the environment if the specialized algae gets out of the refinery?
Currently, the algae refineries we have are closed system, meaning that they're completely enclosed and there's no risk of algae escaping. However, there are currently scientists working on genetically modified algae that will be safe to grow in open systems.
Will I have to alter my vehicle to use algal-derived biodiesel?
Yes, you would have to alter your vehicle. It would be the same type of kit used to currently modify your car if you wanted to use the currently ethanol-based biodiesel we have on the market today.
What is incident sunlight and how is it different from sunlight needed for solar power?
Incident sunlight is the sunlight you would get on a cloudy day, or it would be the type of sunlight you would get at dusk or at early morning. Typically this is enough to grow any type of algae, whereas solar power needs algae that is, needs sunlight that is direct. If it's cloudy or if it's dusk, you're not going to be able to produce the amount of energy that you need. Thank you.